All right, so this lesson, we're going to talk about the musculoskeletal system as well as the nervous system. These are the remaining two systems that we have yet to talk about from all of our organ systems. There's one more that we're not talking about, the excretory system. You don't have to worry about that. But for this one, we're going to talk about the skeleton, your bones. Inside the skeleton, we're going to talk about the cartilage. Attached to the skeleton, you have the muscles. And then afterwards, we're going to talk about your nervous system, which includes your brain and your spinal cord, what they're made of, so the neurons, and how all of your systems can work together to keep you alive. So starting with your bones and your skeletons. So this is called the musculoskeletal system, so muscles and skeleton. They work together, okay, to enable you to move and to stand. So bones are pretty much all, they all have muscles attached to them, and muscles, if you're attached to bone, this allows movement of that bone. Okay, so they protect, they protect the organs. So you have a rib cage, it protects your heart. You have a skull, which protects your brain. So your bones are very useful. Not only does it support you in order to stand, it also encloses some important organs. Okay, so that's the muscles and the bones. And then we're going to look at each in detail. We're going to first talk about the bones in detail, and then we're going to talk about the muscles. So a bone is not just a piece of bone. There's stuff inside. Okay, if you ever eat like meat, and there's bones. If you crack it open, you can see some red stuff, and those are the bone marrow. Okay, so bones, first of all, it is a connective tissue. Okay, we learn about the four tissues: epithelial, nervous, muscle, and connective. Bones are connective tissues. A bone is made up of calcium and phosphorus. Okay, so the hardness, calcium and phosphorus, they don't really dissolve in water, so they typically form minerals. Inside the bones, if you break apart the calcium, it's not just pure bone. There are cells inside. There are nerves inside and blood vessels, which is why if you snap a bone, that's gonna hurt. Okay, a fracture, if you ever break something, if you're that unfortunate to have broken in any bone in your body, and you can tell that that hurts a lot. Okay, even a tiny fracture in your hand, not even a break, just a crack, that's going to hurt because there are nerves which connects to your brain, which senses pain. Okay, so when I was a kid, I broke my hand. I was riding a bike and I fell and landed on my hand. When I got up, I felt that, okay, my hand felt there's something wrong. It hurts. It shouldn't hurt this much. And I couldn't move it. So I went to the hospital and I took an x-ray. Yeah, I fractured my bones. I need to get a cast. Oh, that hurt for days. I couldn't sleep at night. And sometimes I would twitch by accident and just move my muscles a little bit, and that wakes me up at night. So it's not a pleasant experience because bones have nerves. Okay, and of course, if you snap a bone, there will be bleeding because there's blood vessels in there. And these are all encased inside a piece of calcium mixed with minerals of phosphorus, and they're all over your body. Okay, so that's your skeleton. Well, the skeleton, if you look closely, there are actually three types of tissues within just the connective tissues of bones itself. There's bones, okay, the hard part. There's also the ligaments and the cartilage. Okay. First of all, the ligaments. If you look at the picture, you can see where the ligaments are pointing to, those elastic band looking white thingies. Ligaments are connective tissues that connect bone to bone. Okay, it connects two bones together. And also between the bones, you have these white discs. Okay, those are the cartilage. they have really low friction so that your bones can move around without damage. If you just scrape two bones together, it's like you're scraping two pieces of furniture together. You're going to damage itself. But if you have cartilage, this softens it, this smoothens it, so you don't damage your bones. There are some people that have deteriorating cartilage. They don't really have it. They either removed it via surgery or they've injured themselves. So those people, their bones will bruise more easily. So these people can't engage in a lot of physical activity. And if they do, that's going to damage their bones. And a lot of athletes have that surgery. They decide to play sports anyway because that's their living. Okay, so the cartilage provides low friction support so that your bones can move safely without harming itself. Okay, so please note the difference between ligaments and cartilage. Okay, let me repeat that. Ligaments are little tissues that are like kind of like elastic bands. They connect bone to bone. Cartilage also connects bone to bone, but their job is to provide a low friction surface so that the bones can rub against itself and not damage. Okay, so there is the muscle, which they're attached to bones. Okay, and if you look at muscles, muscles are fibrous. They're made up of little muscle fibers bundled up into like a giant cord. And those cords all bundle up into a giant muscle. Okay, and before I get into the types of muscles, if you look at the picture, this muscle is attached to a bone, which makes it a skeletal muscle. How do muscles attach to bones? Well, there's a little white bit. We call it the tendon. Okay, muscles attach to bones via tendons. So please don't get these words confused. Okay, tendons are what muscles attach to bones with. Ligaments are what bones attach to bones with. So if you're attached to a bone, you are a skeletal muscle. Okay, and these type of muscles allow you to move together with your bone. If your muscles are not attached to your bones, those are called smooth muscles. Okay, you can't really control these. You can only control skeletal muscles. Your brains can control it automatically. You can't take over. Okay, so for example, there are muscles in your intestines and stomach and the esophagus. These muscles allow digestion to happen. So that's how stomachs can churn and literally physically grind the food. You can't control that. You can't tell your stomach to not digest. Okay, your brain will do it for you. You can't turn it off. So you have no voluntary control, hence involuntary. And these are the smooth muscles. And there are smooth muscles inside of your body, inside of your organs. There's a third type of muscle, the cardiac muscle. Okay, cardiac refers to heart. So your heart is a piece of muscle that never rests. So that is different from the other two. They're only in the heart, and we just simply classify them as cardiac muscles. Do we have any questions regarding the types of muscles, how they're attached to bones, and their structure? We're good? Okay. If you go to the gym, okay, and you exercise, and most people at the gym, their favorite things to do are either the chest muscles, the pecs, or their arms. Okay, a lot of guys like to look big, especially if you have buff arms. People think that looks amazing. So there are two muscles in your arms. Okay, you have the bicep and the tricep. When your muscles respond to something, it could be a signal from your brain in response to, I don't know, I need to pick this up. So you see something you want to pick up, Your brains will send a signal to your muscles, and then your muscles will contract. Okay, it will shorten so that the muscle becomes smaller but more bulgy in the middle. So if you take out your arm, you can't see that properly on my camera, but just take out your own arm, feel your biceps, and when you contract your arm, you can feel that it becomes shorter and more bulgy in the middle. That's muscle contraction. That's how you do this movement where you fold your arms in. Your bicep contracts, your tricep on the other side, it becomes longer, it relaxes. Okay, but if you want to flatten out your arm, this action here is done by the triceps by contracting and becoming shorter, and your bicep relaxes. These two types of motions are governed by two sets of opposing muscles. They work together to allow movement in different directions. All right, if you ever forget which muscle does what action, just try it. If you go to the gym, you pick up some weights and you keep doing this. Okay, the next day, your biceps are going to be very sore if you don't go to the gym a lot. If you regularly go, then you're not going to feel anything the next day. But if it's just like your first or second time, you just keep doing this. You're using your biceps. You're lifting, you're curling like this. This pulling motion uses the bicep, not the tricep, which is why only the bicep will hurt. Okay, if you go to the gym and you do bench press, you push things, or you do push-ups, the pushing action uses your triceps, which is why after doing a lot of push-ups the next day, your chest will be sore, your triceps will be sore. Okay, there are some other muscles that you use, but mostly these two, they will be the most sore. So just if you're going to work out, know what you're doing, know which muscle you're working out. The bicep or the tricep, if you're going for the arms, they're different. They use different motions because they're the opposite. So do we have any questions regarding how your arm muscles work? How do you flex your arm? How do you relax? Good? Okay. One last thing about bones, you can have this disease. This is actually pretty common in older people. It's called osteoporosis. A lot of you may have heard of this already. What do you mean when you have osteoporosis? That means you have a lower bone density. Okay. This is linked to a loss of calcium. Calcium builds bone. Okay, bones are literally made of calcium, which is why a healthy supply of calcium is vital for bone health, which is why drinking milk, which contains calcium, and as well as vitamin D, this can help prevent osteoporosis. Once you get it, it's not something that we can cure, but it's not fatal. It's just your bones become more brittle. You can break it more easily. And if you have a calcium deficiency, you likely have brittle bones. I don't know if this was an accident, but for me, I'm very tall. So I broke my bones 3 times, okay, throughout my life. And yeah, that wasn't fun. For some reason, every time I fall or, crashes a car, I break something. I told you, I rode a bike, I broke this bone. And then in grade 10 phys ed, I was playing football. Flag football, you're supposed to grab the flag and you turn over the ball, but somebody wasn't paying attention, which is why you should pay attention to what your teachers are saying, especially in phys ed. So this kid in my class, he wasn't paying attention. Okay, so I got the football, I was running for a touchdown, and he tackles me. He wasn't supposed to, but he did. We weren't wearing any protective gear. If you look at the football players, you have like a full set of gears, helmets, shoulder pads, everything. I got none of that. So I went flying. I was pretty skinny back then. So I landed on my wrist and I broke the bigger bone. Now, there are 2 bones in your arm, the radius and the ulna. The bigger one completely snapped. Oh boy, that hurt. So that was the second time when I broke my bone. That took like more than a month to heal. Man, I got a really good mark for that class though, because I had to sit out the rest of the semester. I had a pretty good mark at that point, so that was it. Third time, my dad drove me to university. During the blizzard, a car crashed into ours, and the airbag hit my arm. It hit my little finger here. That's why it looks kind of crooked. Yeah, 3 times. Normal people don't break their bones ever, but yeah, for me, I probably have low bone density because I grew too quickly, and I don't drink milk at all. I hate milk, so I probably need more calcium. So just tips, people, heads up. If you're a tall person, you don't want brittle bones. Not all animals have bones. We have bones, okay, because we are vertebrates. Vertebrates refers to animal with a backbone. So if you want to call someone spineless, you can call them an invertebrate. That means saying you have no backbone. We have muscles attached to our bones, and our bones are inside of our skin. Okay, I shouldn't see your bones when I look at you. If I can see your bones, there's something seriously wrong. There's a comment. Oh, wow, there's a lot of comments. I'm not getting notification today. Sorry. Cardiac arrest, when muscles don't. Exactly. Cardiac arrest means your heart stops pumping blood, and that can be fatal, so that you need to restart that heart immediately. That's literally what that means. So why old people always break their hip? Yes. Okay. Old people, when they slip and fall, they break their hip because they have lower bone density. This is something that everyone gets when they're older. It's just different severity. If you slip and fall in the shower, and the older you are, the higher the probability of you breaking something. I slipped in the shower this year in May. Okay, it was in the morning. We were doing online classes. I was taking a shower and I slipped. I landed on my ribs, and boy, I sat there for like 20 minutes. It hurt that much. I was like half passed out. But being a great teacher that I am, I crawled out of the shower. I logged into my online class, and in pain, I grinded through the first period. It was 3 hours long. I wanted to die. In the afternoon, I have another class at 1 o'clock. They came back. 30 minutes into the class, I was like, nope, I'm done, guys. I'm in too much pain. Find my lessons on YouTube, and I'll see you tomorrow. So I passed out, and I asked people to call 911 because I thought I broke a rib because it hurt too much. I thought I broke something. So I called 911. People showed up, took my temperature because of COVID. And so they asked me, how old are you? I'm like, I tell them my age. I'm not going to tell you my age, but I told them my age. Like, oh, God, you're too young. We're getting out of here. You don't need to go to the hospital. You don't need us at all. You're fine. Bye. Like, no. I was like, what, seriously? You guys are not going to do anything about that? They're like, no, just lie in bed and you'll be better in 1 or 2 days. Yeah, it was so painful because I wasn't an old person. At my age, if I slip and fall, there's a really small chance that I'll actually break something. So they did not care about me at all. Okay, anyway, I broke my finger once. What do you mean a figure? I'm thinking finger. Didn't really hurt. Finger, right. It only hurt when they wanted to put it back. Yeah. Okay, see, again, pain is subjective, right? If you don't look at it, if you don't know that it's broken, it actually doesn't bother you all that much. The moment you look at your fracture and it starts to hurt, your brain starts to say, oh, that should be painful. And all of a sudden, you feel all kinds of pain. Okay, I can attest to this many times. When I broke my finger, I didn't even know it was broken. I went to the hospital anyway because it was a pretty bad car crash. I got some x-rays, and they found a fracture in my finger. It didn't hurt, but when I moved it, it hurt. So yeah, I can imagine what you're going through. They have to put the bones back, otherwise it doesn't grow properly. Yeah, they have to pull it apart, align it properly, and then put it back, put a cast around it. Yeah, that hurts a lot. And every time you twitch your fingers or something, not fun. Anyway, there's another one. I've had that too. Oh, God, it took me a while to notice. Yeah, again, we can actually sustain a lot of pain, right? We go through pain all the time. Most of the time, we don't care because we know, okay, we're fine. We're normal. I bumped my knee on the tree. Okay, I'll just get up and keep walking. So a lot of time we ignore pain, but then when we break something, we really focus on the pain, and knowing that it is broken will hurt a lot. So when we fall from a certain height, that can be pretty dangerous for us because we have bones on the inside of our body. Why do you have to get surgery for some broken bones? Okay, here's why. I didn't get surgery on my finger, and look how bent it is. Okay, the doctors recommended I get surgery to piece together those little broken fragments so that it will grow properly. It's a really complicated surgery. I'm like, no, I'm not doing that. So, okay, fine. Just let it heal, and this is what happened. It's crooked. So, yeah, some bones, if they shatter, you need to put the pieces back. Then they will heal. If you don't, you're going to heal in a deformed way. Yeah, see, there we go. So if you break something, it depends on the severity. If it's pretty bad, and if it's like a large bone, yeah, you better get surgery and have that fixed. If it's something tiny, I knew that it was going to be crooked, but I didn't lose any function, so I'm okay with that. Okay, so it depends on how shattered your bones are. Sometimes they have to literally piece it back together. Okay, so just talking about that just sounds painful. Anyway, if you don't have bones like these fellas here, these invertebrates, they don't have bones on the inside of their body. Actually, they don't have bones at all, but they do have a shell. We call those exoskeletons. These creatures, you can drop them from a higher place and they can fall. They won't be damaged as much as we will be dropping from the same height. It is because they do not have internal bones to break, and they have a fluid inside their body, and all their organs are bathed in that fluid. And if you drop something, the fluid will cushion the fall, which is why you can't kill insects by dropping them. Okay, they will hit the floor, they'll just keep walking, will fly away. You need to really crush their exoskeleton in order to kill them. Okay, so these are a little bit different. They have, well, they're not bones. We call them exoskeleton, outside skeleton. They're actually made of something different. They're made of chitin, which is a kind of sugar. Sugar doesn't have to be sweet, so don't try to lick a beetle. It's not the same thing as our bones, but they have pretty much the same function to keep things out, to give them structure. So we call it the exoskeleton. What our skeletons are on the inside. Okay, so moving on from skeletons, do we have any final comments or questions about skeletons or bones, muscles, anything? Okay, well, see, if you break your bone, no problem, right? You can still carry on. It will heal. Wait, can humans get what the insects have, like in a lab? Okay, insects have a lot of things we don't have. I don't know what you're talking about. If you're talking about exoskeleton, no. Like a shell, no. We are too different for us to just copy what insects do. Okay, like even if you graft the DNA in the insect that tells it to make an exoskeleton, we will lack too many things to make that work, despite speaking the same DNA language. You see what I mean? It's kind of like different countries with different political systems. You can't just go to one country, copy their political systems and economic ideologies exactly and apply to your own country and expect it to work the same way. It doesn't work that way. Okay, the United States are trying to do, actually some of them are trying to do what Canada has, like free healthcare. But a lot of people are arguing that America can never have free healthcare like Canada, because I actually don't understand that argument, but that's what they think. Okay, so you can't just copy paste. No, we can't have exoskeletons and fluid on the inside because we're too different. And the fluid, yeah, no, that is not something that we can genetically engineer, even if we tried. We can do something subtle, like give us a gene to grow longer hair. That could be a thing. Or give us a gene to have perfect vision. Sure, that's easy to do, but things like exoskeleton, no, Those are for arthropods. They're so different from a vertebrates that it's just not going to work. Anyway, if you break your bone, you're fine. You can still survive that. But if this damages the nervous system, chances are that you will either be permanently disabled in some way or dead. Okay, so the nervous system is basically your brain and the spinal cord. Okay, so these are the control centers of your body. You are conscious right now. Hopefully you're conscious right now because of your brain. Okay, you can learn, you can feel, you can think, you can keep your body alive because of that thing in your head right now. But if you break your spinal cord, you can die or be paralyzed. Yeah, it depends on where you break it. The spinal cord has many important functions. It is enclosed in our spine, the backbone. So breaking a bone usually means it will heal, but breaking your back is something completely different. It is not the bone that we worry about. It's what's inside the spinal cord. If you break your bone at the lower back, you will become paralyzed because your legs are controlled by the spinal cord. If you break that connection, your muscles in your legs are fine. Okay, the bones in your legs are fine, but they will never move again because your brain is now unable to send a signal to your leg to tell it to move. So despite having perfectly great legs, you broke the connection at the spinal cord, so that person will become a paraplegic for the rest of their lives, unless they fix their spinal cord, which is impossible given our current technology. So hence stem cell research is a potential cure if we can get it to become a spinal cord to replace the dead ones. So with full body paralysis, yeah, so it depends. If you break your neck, yeah, that's full body. Not even your upper your hands, they can't move anymore because it depends on where you break it. The more functions will be lost. So no, do not break your neck. Okay, if you break your neck, you're probably dead anyway. If you break your upper back. Okay, so the central nervous system. There are two types of nervous systems, okay? The central and the peripheral. Can you 3D print a bone? Yes, you can, but that's not what we care about. We don't really care about the bone. We care about the nervous system. You see what I mean? So some people do have artificial things in their body. If you break your back, does the cutting off of the blood flow kill you? Or is it something else? Breaking your back usually doesn't kill you. It paralyzes you. If you pierce an organ, that's a different story. It's organ failure that kills you. But just simply snapping your back, you're just paralyzed. You're not dead. Yeah, not everyone breaking their backs would die. Yeah, that is correct, but that is not something that you want to do. It's irreversible. Okay, the nerves have to. Wait. What does that say? Oh, can't we put the little pieces? Yeah, if you break the spinal cord, the spinal cord is not a bone. The spinal cord is made up of the same thing that your brain is made up of. It's kind of jello-ish. So yeah, you can't exactly piece that back. It's like if you break a piece of wood, gluing it back, sure, it is still structurally sound, but those nerves will never connect again. Okay, you can't just piece the nerves back. That's the problem. Anyway, central nervous system versus peripheral nervous system. So the central nervous system, if you look in the picture, the brain and your back, the spinal cord, okay? Those are central. They're in the middle. The peripheral, the English word peripheral means to the side. So your peripheral vision is what you can see with the side of your eyes. Peripheral nervous system refer to those little nerves that come out of the back. Those are peripheral, okay? They do different things. The peripheral connects the body to your central nervous system. Okay, so any questions about that? You can reconnect nerves, yes, but your central nervous system is not just a nerve. It is way too complicated for us to connect. If you break a finger, sure, you can connect that nerve, but if you break your central nervous system, we don't have that technology right now. Okay, so your brain. This thing is not probably like the most complicated thing in the universe. Okay? There are many things in the universe. The universe is big, but nothing is as complicated as your brain. Even the best supercomputer is not this good. Okay, computers, yeah, they can do a lot of things humans can't, but then also humans can do a lot of things computers can't. So a computer is really difficult for a computer to mimic a person, because people have different attributes that computers will never mimic, like emotion, creative intelligence. So that's kind of difficult. So this is so important. There are many protection mechanisms that your body have just to keep it safe. First of all, you have a skull, and that's your number one protection. And then inside the skull, you have some fluid. So even if you hit your head, you get a concussion, that means your brain jiggles in that fluid. But the fluid is there to cushion. It's like you have your natural helmet, your skull. And inside, there's also a blood-brain barrier to prevent viruses and bacteria from entering your brain. So it's important. You cannot live without it. You can live without many organs, or at least survive for a little bit. But without the brain, instantly you are dead. So this is part of the central nervous system, and it has so many functions that in grade 10 science, we will not go into the details. We'll just briefly look at what some parts of the brain can do. Okay, in the central nervous system, is it spinal fluid? The brain is in it too. Yeah, that's right. Your brain and your spinal cord are both bathed in fluids, exactly. So yeah, your spinal fluid is really your brain juice. Okay, we good? Alrighty. Okay, so now we're talking about the spinal cord. So your brain is attached to the spinal cord. So there is this tube structure that goes down your spine. And this in the picture is a cross section. Imagine you took a spine, you cut it in the middle, and you look. The spinal cord is that tiny round thingy in the middle. There is a dark gray butterfly looking structure. Okay, that whole thing is the spinal cord, and those yellow things coming out of it are the nerves. Okay, the rest of it are bones. So it is inside our backbone. What does this do? Well, your spinal cord is that first stop before it gets to your brain. Your spinal cord can dictate movement and how you react to the outside environment. For example, you take your hand, okay? You put it on something hot, like a stove. When you put your hand on the stove, that's going to hurt. Immediately, your reflexes will move your hand away. You're like, oh, and then you do this. Okay, that's without thinking. You don't need to stop and wait. Hold on a second. I think this is hot. Yeah, I'm going to take that. If you process it in your brain, that's wasting time. Okay, and that could be irreversible damage. So you need to react as fast as you can. So just make the decision, move your hand away. That's a reflex. You do it without thinking. So what happens is the heat is detected by the nerves in your hand. Those nerves, they send a signal to your spinal cord, not even the brain. You don't need your brain to make that decision. The spinal cord. The spinal cord will send another signal back, move your hand now. Okay, so the muscles get that message, you move, and you don't burn your hand even further. Okay, if it travels all the way up to your brain, that distance takes time. Okay, if a student collapsed in the classroom with foam coming out of their mouth, I'm not gonna call the office. Hey, someone is on the floor twitching. What do I do? No, I'm just gonna perform something. Call 911 immediately. Try to save. Don't waste time. Okay. Whoa, many messages. Okay, let's see. how far does this go? What happens to people who have to get a part of their brain removed? I don't know any examples of this. All parts of your brain are important for something. If you have to remove parts of your brain, you're likely dead. Okay, so here's what happened. This is the closest example that I know of. Phineas Gage. Don't know if you heard of that person. Phineas lived a long time, like 18 something. Okay, he was a railroad worker. Phineas, if you ask his colleagues, they're going to say, yeah, Phineas is a great person. He has a great personality, very charitable. He always does his work perfectly. He works hard. Basically, everybody loves him. Okay, very nice person to be around. One day, working at the railroad, there was an accident. A railroad spike, a giant metal pole, pierced through his eye, out of his skull, and miraculously, the dude survived. So he went to the hospital. The doctor was like, holy crap, all right. The doctor carefully removed that metal spike. Like, patches up the eye, patches up the skull, and later Phineas woke up, and nothing really happened to him, except one thing. He now becomes very grumpy, easily angered. He cusses a lot. Like, he never swore before, but now, like, the F word, S word, or whatever. If anything doesn't go his way, he flips the table, he cusses at people, he blames others, he becomes lazy. So what happened to him? Well, emotionally or personally, he's changed because a part of his brain was damaged. And it turns out that part of the brain is responsible for self-control and compassion. He lost those functions because a railroad spike killed those cells. So he's changed. So that is one example I can think of where a part of your brain is non-functional and yet you're still alive, but there are consequences. Okay, if you have damage to any part of the brain, that function of that part of the brain will be lost. Okay, I don't know if that makes sense. So basically what Marwood said, you will lose function in that part of the brain. Oh, okay. Epilepsy. You don't remove half the brain. If you have like you cut off the connection between the left and the right brain. You still have those parts. Okay. There was a young guy who got the hippocampus removed. Oh, okay. Yeah, that I did not hear of that example, but yes, your hippocampus is responsible for memory. So if you have that removed or you broke it, then yes, you cannot form long-term memories. Or you cannot form long-term memory. You won't remember anything. Short-term memory, yes. Like if I tell, hi, my name is William, they're going to remember that. Next day they forget. What? I don't know what those words are actually. Oh, okay. Yikes. Hemispherectomy. Okay, I've never heard of that. Well, that sounds terrible. Is that like removing half of your brain? I highly doubt that person will be alive if remove half of their brain.
When they remove it when they're young, so like their brain's able to adapt and they can live like pretty normal lives.
Pretty normal lives with half your brain, really.
Yeah, it's crazy, but I think it's like it works.
Okay, I'm gonna look that up because that's actually very fascinating. If you can live on half of your brain, if you remove it early enough, then that's okay. That's interesting. Anyway, so let's move on. So the peripheral nervous system, it's divided into 3 groups. Okay, so I'm going to show you the groups. I'm talking about that nerve, that yellow thing that's coming out of the spine, the peripheral, not the central anymore. So you have nerves that control voluntary muscle movement, like the example I gave you. You put your hand on something hot, you move it away immediately. That nerve that carries the information is the peripheral nerve. Okay. Also, sensory information. On a hot summer day, you're very thirsty. You see a glass of ice water in front of you. Your eyes, your ears, what you hear, what you feel, those are sensory information. Your eyes detect something, the nerves go to your brain, and your brain knows about it. Okay? Or when you hear something in your ears, that sound wave is picked up by a nerve and it goes into your brain. Same thing, if you touch something, the nerves inside of your fingers senses whatever you're touching, it sends a signal to your brain. So those are also the peripheral, the sensory information. And also there are nerves to control involuntary functions. Breathing and heartbeat, they're both involuntary. You cannot opt to stop beating your heart. Okay, well you can in the short term stop breathing, but you can't permanently stop breathing simply by willing it. Okay, putting a plastic bag around your head is not voluntarily stopping you breathing. Like, I mean, I'm talking about just hold your breath forever until you die. That cannot happen because you will pass out and your brain will just take control and start breathing and you will wake up a few minutes later. Okay, so 3 things: voluntary muscles, sensory, and involuntary control of your organs. So those are your peripheral nervous systems. As you can see, that's also very important. Okay, so do we have any questions about the vertebra? Alrighty, so the structure of nerve tissues. So your brain cells, we call them neurons. Okay, there are special names for these cells. Neurons are different from regular plain old cells that we've learned in lesson 1. Okay, regular cells, first of all, they're kind of blobby and globular shaped, and they don't really conduct electric signals. But these cells, they're more shaped like wires. Okay, they still have a nucleus, and a cell body, but they have this long wire to them and some connections at the end, kind of like an alien. And these connections make connections with other cells, which forms a giant network, like a computer with wires of network, that forms your brain. Okay, so these are found in the brain, the spinal cord, and your nerves. And ultimately, the nerves can connect to a muscle, which then feeds information to the muscle and senses information from the muscle. So these are basically wires. Like, actually, they're literally wires, biological versions of like a computer cord. Okay, so we are really similar to machines. Machines are probably inspired from biology. We just simply made an artificial version of that. Okay, so these conduct electric signals all over your body from your brain. So we run on electricity. Okay, does that make sense? Which is why we can get killed by electricity. If enough like current goes through our heart, it will stop it because the heart, like the brain, runs on electricity. We can short circuit ourselves. Do we have to learn about the synapses? I'm glad you know about the synapses. No, that is grade 12 biology. We're simply learning the basics. Okay, nothing detailed. We don't have to learn about how it conducts electricity. Again, those are grade 12. So basically on this page is all you have to know. And by the way, if you just look at the enlarged diagram to the right, a nerve, it is like a bundle of tiny wires, and those are the nerve cells, the neurons. And that yellow sausage-looking thing that wraps around the nerve, they're called the myelin sheath. Okay, those are important for your brain function. Without them, the signals will be very slow and a lot of things will happen to you. And there's a disease we will talk about a little bit later that relates to that. So the senses, we all know about the 5 senses, right? Smell, taste, touch, hearing, and vision. Those are the 5 senses. We only have 5 senses, right? Is that correct? Or do we have more? Anyone? We have more. Yeah, we don't just have 5. you have many other senses. In addition to our 5, we can sense the temperature. We know when it's cold outside. That's a sense. We can sense pressure. Okay. Pain. That's a sense. Some people can lose their capacity for pain, and that can be very dangerous. We can balance ourselves. Like walking has to be learned. You're not born with the ability to walk. You need to learn how to balance yourselves. And sometimes I don't know if you've ever been to like, I don't know, like a science center or something like that, where there's like a fun house where all the walls are kind of built slanted so that there is an illusion that there is an earthquake. When you stand in, your brain doesn't know how to process all of this because your brain always thinks that walls are standing up straight. When you walk into that house where everything is built slanted, your brain will think, oh, there's an earthquake, you feel dizzy, and you lose your balance. So that's also one of our senses. The sense of position, you know where your body parts are. If you close your eyes, you can still eat just fine. You won't put the spoon into your nose. You still know where your mouth is. If you close your eyes, you can still know where your ears are. You can know where your nose is. You can know where your fingers are. Look, my eyes are closed, but I can do this because I know the position of my body parts in space because of that sense. Okay, and we can detect motion. So there are many senses in addition to the 5 that we know. Okay, so don't think that we only have 5 senses. So here's the disease I was referring to. The myelin sheath, that sausage-looking thing that covers up your neurons, your brain cells, if that becomes damaged with this disease, okay, it's an autoimmune disorder. People that suffer from this, their own immune okay, I'm just going to keep talking. The people that suffer from the disease, their own immune system will attack the myelin sheath and destroy it. Okay, you're attacking yourself, essentially. And if that happens, then your brain will slowly become more numb to sensations. And you process things slower because the whole point of the myelin sheath is to speed up your processing. Okay, so your brains will not be effective, so your muscles are weakened because your brain have trouble sending a signal. Speech becomes slurred because talking also is controlled by the brain. Of course, walking, your muscles are not working properly. And this will slowly get worse because this is irreversible. Once it's damaged, you can't stop your immune system. You slowly die. Okay, does that make sense? So this is a really unfortunate disease. We call it multiple sclerosis or MS. Okay, that's actually very common. I'm pretty sure you've heard of it. If you go to, let's say you go to buy some fast food like A&W, on some days they're gonna ask you, would you like to donate to the MS Society or make a donation to MS? Once I ask them, what's MS? They're like multiple sclerosis. I'm like, oh, okay. So you have the option of donating to certain things like MS. So that's what it is. Now you know what MS does to the body. And there is no known cure, which is why we need to donate money so that we fund research to find a cure. Okay. Which reminds me, very hilariously, I'm going kind of off on a tangent here. I sometimes get emails because I post YouTube videos, and if you leave a comment, I didn't disable the emails because I don't get a lot of comments, so I didn't bother. Sometimes I read the comments. It's hilarious. Some people just post that, there's this miracle doctor. Here's their name. Here's their email. They saved me. They cured this. I forget what disease they were talking about. Uncurable diseases. Basically, they cured with a herb. All right. And they just leave that comment right there. I'm not going to delete that because I find it to be hilarious. I'll show you the comments if I remember after this. But this is a good exercise in critical thinking. Why don't people believe them? Why did they have to resort to people posting on YouTube channels? If they can cure cancer, wouldn't they be more famous than Einstein right now? Where's your Nobel Prize? How come I've never heard of your name? So you see what I mean? Anyway. Let's move on to the interactions of different systems. So far, we've learned many different systems: the circulatory system, the heart, the digestive system, okay, your stomach, the respiratory system, your lungs, your muscles and bones, and your brain and spinal cord. They all work in tandem with each other, especially the circulatory system. So in the picture, okay, just look at the picture and notice that the circulatory system, that red circle, well, it turns blue, but that circle in the middle, that represents the circulatory system. Look at how many systems that interacts with the circulatory system. On the bottom, you have food going into the mouth, exiting your anus to become poop. Along the way, you have to interact with the circulatory system. Nutrients gets absorbed into your veins and arteries, which gets carried to everywhere else in the body. Okay, and also the respiratory system, the blood vessels needs to go to the lungs, to the alveoli, so that air can come in. Fresh oxygen is being carried into the blood, and then it will go into the muscles to supply muscles with oxygen. That's how it keeps moving. And also, we didn't learn about that one. Your pee. How do you make urine? Urine comes from your blood. Okay, you pee out bodily fluids, and that liquid is the liquid from your blood. It's not supposed to be bloody because your kidneys will block red blood cells from entering. So you're not supposed to pee blood. If you do, then there's something wrong with the kidneys. Okay, so where did that liquid come from? Your blood. So your blood is so important that it covers all bases. It works with all the other systems to keep you alive. Okay, does that make sense? Any questions? We're good? All right. So we've talked about the different systems. We've talked about the different organs. What if, okay, here's where it gets interesting. What if some of your organs fail? You kind of need them to survive. If you don't have a certain organ, or a certain organ is damaged beyond repair, you're going to die. But can we do something about it? Well, yes, we can. Okay, organ transplant is now a thing. You can take someone else's organ, put it in your own body, and hope for the best. Okay, now it doesn't work every time because of compatibility issues. Now, this is a possibility though. So if you are in need of organ implantation, you need to wait in line. They put you on a list, and if you're next in line, then you get the next available organ. And usually people just die on that list because the line is so long. So I guess you can bribe people to skip the list, but I'm not going to teach you how to do that. All right, so there are certain things that can be transplanted, like your retinas, your eyes, your lungs, your heart, your kidneys, liver, intestine, and pancreas. These, even your bone marrows, these can be transplanted. Okay. Now, I have a quick question. Where do we get the organs to transplant with? Where do we get those from? Anyone? From other people. Yes, we cannot grow them ourselves. Okay, so that means we need donors. Okay, from dead people. Not always. Not necessarily. They don't have to be dead, but a lot of cases they are dead. Okay, like right before they die or when they die. Sure, but you don't have to be dead to donate your organs. There are some organs that can be donated while you're alive, and after you donate it, you can still be alive. See, like I could donate you my heart when I'm alive, but after I do, I won't be alive. But that's not something that I'm looking to do. Okay, so I did some research. I don't know how accurate this is because I don't really have access to the black market, but I snooped around the internet. I found some numbers. Again, take these with a grain of salt. They won't be on the test, obviously, but just out of curiosity, how much are you worth? Like, I'm talking about monetary value. If you get kidnapped, how much money can that person get from you? You see what I mean? Like, they can ransom your parents, and hey, I want $5 million. The parents like, nope, hangs up. You got the wrong person. Like, I mean, do they really just waste their time? Not necessarily, because you're worth more than you think. Okay, don't let anyone call you worthless, because you, at the bare minimum, can be stripped for your parts, and just add up the numbers in your head. More than a million, I want to say. Like, a little under a million. So if you really want that next iPhone and your parents won't give it to you, which organ can you sell to get that iPhone? I'll give you 5 million to keep them. No, for real. I'm being serious right now. Which organ can you sell? I'm not saying you should. I'm not saying that I'm encouraging that you sell your organs for the next iPhone. I'm saying if, when push comes to shove, which organ can you sell? Okay, I'm getting a lot of kidneys. Yes. Okay, you can sell one of your kidneys. Now notice I said one of your kidneys. You got two of them. You only need one. So you can sell one for $150,000, buy the new iPhone and some, okay, and still live a relatively normal life. You only really need one healthy kidney. But, that's not advised, because A, that's illegal. And B, there might be complications. What if your kidney fails? You only have one. All for the PS5. Both. I don't think you guys are that poor. For yeah. If you're kidnapped and you wake up in a bath with ice, if they're... Okay, they're probably bad people. If they're gonna harvest your organs, they're probably bad people. But if they have a slither of morality left in them, they take one kidney, not both. Because if they take both, you're dead. If they take one, you can still call 911 and get rescued. You can have mine for free. Oh my goodness. Okay, so yeah, a kidney is something that you can donate while you're still alive. All right, and there are people that donate their kidneys to a loved one because they have kidney failure and they both lived. So there are risks and benefits of organ transplant. Well, the benefit, I'm just going to list them. They can live a healthy life once they get a new organ. The donor has the satisfaction of knowing that you saved somebody. Okay, that's actually a thing. You feel good about helping others, especially when you save their lives. Okay, and also we learn knowledge about the human body. The risks, well, you can die. That is definitely one risk. You can die on the table. Another risk is that transplant can fail. Okay, that means you wasted not only your time and money, but also your organs.
Can't the donor reject the organ?
Yes, that exactly. This is how it fails. Sometimes, okay, your body will reject the new organ. Now, this is due to your body's own defense system. Your body does not want anything foreign inside. If they detect a kidney that is not your own, because these are not your cells, the immune system will attack. Okay, because they're trying to protect your body from this invader. And in this case, this is not an invader, but your body doesn't know that. So it will destroy the new organ, which leads to organ failure. The transplant is unsuccessful. Okay, now this risk is always there, but you can minimize this risk by using genetically similar materials. So from a relative, maybe, so you're similar enough so that this reaction from the immune system is not as vigorous. And then you can take drugs to suppress your immune system, to purposely make it weaker so that it doesn't attack your new organ, because you need it. Okay, ooh, comments. Okay, Pearson with something dark, just like always. All right, so I'm talking here, living donors. So a kidney, we talked about that. Or, okay, a lobe of your lung or liver. Not your entire lung, not your entire liver, just a lobe. Because lungs have many lobes, livers have different lobes. You can part with a part of your lung and liver and be fine. Okay, so you can still live a kind of a normal life, but there are probably some inconveniences down the line, but for the most part, you're fine. Okay, people aren't that generous. If one of you collapses and goes to the hospital in need of an organ transplant, don't look to me. Look up. We're not that close. Okay, but if it's my family, then okay, I'll consider it. But if there's a completely unrelated person, doesn't matter how much I like you. Like, I enjoy having you in my class, but I'm not going to give you my kidney. All right. I don't expect you to give me your kidney. Like, Mr. Joe, I really need that 90. Do you want? No. Okay. So most of the time it's a relative, and of course there's risk. But a lot of times the donor is dead. Okay. When you're dead, you have no need for these organs anymore, so it's up for grabs. Well, not exactly. A doctor can't just say, hey, that person died, well, here we go, let's harvest. No, you have to consent. Okay, doesn't your liver regenerate? Yes. Okay, you have to consent. If you go get your driver's license, I don't know how many of you are able to drive. If you're 16, you can get your G1. When I go to Service Ontario to renew my license, there's a card you can fill out, the organ donor card. You put your name down, and this is to give consent that when you're dead, they can harvest your organs for medical and scientific purposes. Okay, I signed that card. The only comment, the only request that I have for them is to make sure that I'm actually dead. Like, try your best to save me and make sure that I am 100% absolutely dead, then take my organs. I don't want to wake up in the middle of the process. Okay, so this is the bulk of the source of the organ from deceased donors. Okay, and also if a person dies and they didn't give consent, the family members can give consent and still have them donate an organ. And there are some really touching stories about like these kind of things. I think I remember from the top of my head, a girl died, still quite young, in her prime, definitely not old. The mother is devastated, but the daughter donated her heart after she died to someone else. So that the mother every year will just go visit that person just to listen to their heartbeat, because that heart belonged to her daughter. So yeah, this can really change lives. So this is something that is more pro than con. That's not really controversial, but you do have to know the risks, the benefits, and the restrictions. What if you are brain dead? Oh, then you are dead. It's the definition of death right there. How do you know someone is dead? If their brain is not working, is dead, they're dead. Like, that's it. There's nothing you can do about that. And that concludes this lesson. We learned about the muscles, the skeletons, the different components of the muscles and skeletons. So know the difference between cartilage, tendon, and ligament. Okay, and also how muscles move, osteoporosis, and the nervous system, the central versus peripheral. What does the nervous system do? What is a neuron? Okay, and some diseases like multiple sclerosis, and also organ donation. Do we have any questions? All right, then. Going to stop this.